Okay, to solve 37, 38, and 39, it says to find the measure of the exterior angle shown. We're going to start with 39 because it's a little bit different than 37 and 38. So for 39, they want us to find the measure of the exterior angle, and it's not actually marked. So I'm going to mark it with y degrees. Now you can use any variable but x. X has already been used. So in order to find y, we have to find the value of x because we know that x plus y is equal to 180 degrees because it forms a linear pair. Now the reason this one's different is because in this particular question we know the measure of the third angle is 90 degrees. So that means these two angles have to be acute and their sum has to be 90. So we have 2x minus 21 plus x equals 90. So therefore 3x minus 21 excuse me, equals 90. So 3x equals 111. So x is equal to 37. So if x is equal to 37 degrees, these two angles have to add up to be 180. So this angle y then would be 143, and that would be the measure of the exterior angle. Now if you wanted to just double check, you might want to plug in here 2 times 37 is 74 minus 21 is 53 degrees. 53 plus 37 is 90. 90 plus 90 is 180. 37 plus 143 is 180. So it all checks out. So the answer for question 39, the exterior angle measures 143. Now, to solve for 37 and 38, we're going to do the proof that we did in class. So I'm going to make it look like 37, but it's going to apply to both. So let's say we have this diagram. Right now, we're trying to find the relationship in these angles. Now, in order to do that, we need to know this angle. Now, even though we don't know its measure, what we now know, without making any assumptions, is that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Interior angles of a triangle have a sum of 180 degrees. We also know that the measure of angle 1 plus the measure of angle 4 equals 180 degrees because they're a linear pair. Not making any assumption, using the rules that we've established so far in this course, we know that these two statements are true. Now given that they're both equal to 180, we can use substitution to set them equal to each other. So this sum is 180, so is this, so this sum has to equal this one. So we have the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 4. What we notice on both sides, we have an angle 4. When we subtract, it cancels out. So what's left behind is the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. So when we refer that back to the diagram, 2 and 3 are what we call the two non-adjacent interior angles, and angle 1 is the exterior angle. So all we started with was a triangle with a single exterior angle, and we proved that the exterior angle measure will always be equal to the sum of the two non-adjacent interior angles. 1 and 4 are adjacent because they're next to each other. That means they share a vertex on the side. So that's always going to be the case. The measure of the exterior angle is equal to the sum of the two non-adjacent interior angles. So what that looks like in this question, the measure of the exterior angle, 2x minus 8, is equal to the sum of the two non-adjacent interior angles. From there, all you have to do is solve for x, and I'm going to let you do that. Once you have solved for x, remember the question is asking for the measure of the exterior angle, so you want to plug in and determine what this angle measures. For 38, again, the measure of the exterior angle is equal to the sum of the two non-adjacent interior angles. So there's your equation, and again, I'll let you solve from there. So that's how you do 37, 38, and 39.